in this video we're going to be checking how to obtain the number of terms in an expansion. Now, most classes, when we have just two terms, for example, if you have x plus y raised to power n, we can say that n plus 1 will give us the number of terms in this. Okay, if for example, if I have x plus 3y raised to power 2, it is obvious that I'm going to be having three terms. That's x squared plus 6xy plus 9y squared. That's what I'm going to get. Okay, I'm wondering how I got that right. This is what I did. Whenever you're having two, it works for only two. Whenever you're having x and y, just two, what you do is you put this, let me write it there, x plus y raised to power 2. What you do is you just put this power on this one, put it on this one, then multiply this one and this one together, then multiply with these two, you get your answer. That is, if I put my 2 on that x, I will have x squared. If I multiply this times, that's xy, right? Xy times 2, that is plus 2xy, isn't it? If I put my 2 on this y, I will have what? Y squared. So I apply the same thing here, put this one here, I have x squared. Multiply this, so that is 3xy, then 6xy. Then I'll put my square on this one, that's 9y squared. But that's not where we are going. That's just a quick one. Now, but it will not always work for all the expansions if you want to know the number of terms in the binomial. So there is a general formula you need to know. There's a general formula you need to know to be able to get the accurate number of terms in a binomial. Alright, suppose you are given a plus b plus c raised to power n. Will you now say that you just plus this by 1 and you get your number of terms? No. So the general formula you want to know whenever you are given something like this is n plus k minus 1 combination k minus 1. Okay, combination k minus 1. That is how to find the number of terms. This is just what you need. N plus k minus 1 combination k minus 1, or you can write it like this, n plus k minus 1 combination k plus 1, k minus 1, sorry, k minus 1. Here, this n means the power, then k is the number of digits in the expansion, number of digits in the expansion. Then we can also use this to find, so we have how many digits here? We have 1, 2, 3 digits, and this is the power, right? So if I want to find the number of things that will be possible in this one, I will just say that n plus 3 minus 1, 3 minus 1. Okay, don't forget the k is the number of digits. So that will be n plus 2 combination 2, isn't it? That's it. I can express this to be n plus 2 factorial over n plus 2 minus 2 factorial. Okay, 2 factorial, and that will be n plus 2 factorial over n factorial 2 factorial. And this can be written as, you can write this as n plus 2 n plus 1, isn't it? The n factorial over n factorial 2 factorial is still 2, so this cancels this. So our final answer in this case will be, our final answer here will be n will be n plus 2 n plus 1 over 2. That will be our final answer. Let's take an example to buttress this. Suppose we are given an example to find the number of terms in this question. Let's say we are given an example to find x x plus y, okay, raised to power 3. So our general formula is what again? Our general formula is n plus k minus 1 of combination k minus 1. Okay, so my power, which is 3, is n. So I have 3 plus number of terms k, that's 2 minus 1, combination 2 minus 1. Okay, and that will be 4 combination 1, and 4 combination 1 is 4 factorial over 3 factorial 1 factorial. That's what? 4 times 3 factorial over 3 factorial times 1. This cancels this, so I have what? 4. So here there will be what? There will be 4 terms here in this expansion. There will be 4 terms, and we can actually see that to be x cubed, right? X cubed plus 3x squared y plus 3xy squared then plus y cubed. I actually use my knowledge of Pascal triangle to solve this. You can check out the video on that. That's how to find the number of terms in an expansion.